Okay, we're going to continue with the next chunk. We're about way through our review. So this is definitely something that I have found over the last several years is kind of a gap with kids that come in to Math 1. It's not something that's been emphasized a lot in earlier math courses. And honestly, it's not something that we really did a lot of in Math 1 in previous curriculum. So it's something they cover a lot in Math 2. And so this is good that we're reviewing this and we're making sure people are familiar with the rules, at least the basic rules of exponents when it comes to multiplying and exponents to exponents and stuff before they go to Math 2. But I know for this first chapter it might be a little tricky, so I'm going to go ahead and I could solve this really in about 2 seconds or less if I know the rule, right? But not everybody has these rules memorized. So what we really want to be able to do is know what this means and see if I could figure it out if I didn't have the rules memorized, right? Because if I, well, I'm going to do it. I know the answer, right? The answer is x to the 8th power. The rule tells me if I'm multiplying, right here, that's what two parentheses mean. If I'm multiplying two terms, right, that are the same, same variables, I add the exponents together, right? If I'm multiplying them, I add the exponents together. So that's really simple, right? But I may not remember that exactly, so maybe I'm going to expand this a little bit just to demonstrate what that looks like and why that works, right? So x to the 3rd, that's just x times x times x, right? And x to the 5th, that is just x times x times x 3, 4, 5 times, right? Well, if I multiply all these together, right, remember all that an exponent is how many times am I multiplying the same thing together? Well, if I look here, now I have 1, 2, 3, 4, 5, 6, 7, 8 x's. So I'm multiplying x by itself 8 times, right? So I could just memorize the rule that if I'm multiplying, like in this simple case, 2 x's together, I add the exponents together, right? It makes sense. X times x, right? If I did it like this, x times x is x squared. Well, that's because this is x to the 1 and that's x to the 1, and I just add them together. But make sure, I don't know, for me, I like to double check this way. All right, same thing over here. I know what the rule is if I have something to an exponent and then I am raising it to another exponent, but you might not have that memorized. So I'm going to do this the long way, right? I have 2x to the 3rd squared, which means I have 2x to the 3rd times 2x to the 3rd. Right, that's all that means. And now I'm going to keep expanding this out. 2x to the 3rd is 2. X to the 3rd is x, x, x. So 2 times 3 x's. Right, and actually this one's identical, so I'm multiplying times another 2 x, 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 right? And now you can see once they're all laid out, I can multiply things in any order. So these guys right here, 2 times 2 is 4. And I have now 1, 2, 3, 4, 5, 6 x's. So 4x to the 6th. That would be how I simplify that right there. So that's the long way. If I can remember the rule, I could go back here and I know, just like on number 7, I had a rule. Here the rule is if I have an exponent to an exponent, I multiply them together, right? So, or anything to an exponent. So here the 2 is going to go with the 2 and the 2 is going to go with the x third. So I would have 2 squared times x third squared, which is 4x to the 6th. Right? Some people in the past have told me it's kind of like distribution, and I don't want to introduce that idea because it's not distribution at all, but it's kind of the same idea that it goes with everything inside there. So however you choose to remember it, it's a lot faster to do this up, do that up there than it is to do the long way, but you should be able to do both. All right. 2 more that have to do with exponent rules, number 9 and number 10. I can see here on number 9, if I look at the bottom, I have a negative exponent. Whenever I have a negative exponent, that tells me it's really the inverse. So I want to move it to simple way to think of it, I want to move it to the other part of the fraction. If I don't want a negative exponent, I'm going to move it to the other part of the fraction. So the first thing I would do, right, we kind of did a lesson about dividing by a fraction. So when you divide by a fraction, you kind of flip it, and then it ends up being multiplied by the top. It's kind of the same thing here. But simple version is if I have x to the -2 on the bottom, I could move that to the top and make it positive. Right, so that's kind of what I'm going to do here first. So I would have 3x to the 10. I didn't do anything on the top yet. And then I have 2, and then this x to the -2. I don't want it negative on the bottom. I want to move it to the top and make it positive, right? And then it disappears from down here. And now I can use those rules that I learned up above, right? If I'm multiplying things together, 3 times x to the 10 times x squared, these two things right here are have the same variable. They're being multiplied together, so I add the 10 and the 2. So 3x to the 12. And then the bottom didn't change. And the last one, I actually could have applied a different rule over there, but I chose to do it that way. Here, there is a rule if I'm dividing, right? We saw up above, if I'm multiplying, right, x squared times x to the third, if I'm multiplying, I might add them together. Well, if I'm dividing variables that have exponents, then I subtract. That kind of makes sense, I hope, because those are inverses of each other. So knowing the rule, this is going to end up being 3x to the 5th. If I don't know the rule, I can expand, right? So 3x to the 8th. So I got 1, 2, 3, 4, 5, 6, 7, 8. 3 and 8x's on top, and then I have 3x's on bottom. So if I look, right, 3x's over 3x's, I could take these three right there and they cancel each other out. They reduce to 1. 3x's multiplied together on the top and the bottom, right, that's a 1, so that part goes away, and then I'm just left with the 1, 2, 3, 4, 5x's. Right, so there's a short way knowing the rule. If I divide exponents, subtract them, and then I did it the long way to prove why it works. Okay, I'm going to stop this video here after that section, and we'll kind of finish up with the last two, and then we're done.